Hi, welcome to another video lessons from videodeveloper.io. Today, we'll talk about Kubernetes and cloud deployment. Also, this can be applied in the context of video, as encoders, which reduce the complexity, size, and optimize for getting the best quality, can be deployed on Kubernetes clusters in order to speed up the encoding of video and also to enable the transcoding and encoding of very high quality video like full HD or even 4K by splitting the load on different nodes and pods. And we will see why this all works together in conjunction with a bit of history. So let's start from there. So initially, we had a situation where cloud wasn't there, right? We had virtual machines or actual servers living in the internet and people would just connect to them. And that's our first case. So we have an application on a virtual machine and the user can reach it. Then we evolved from that. We got into versioning. So we version each file that gets added to a repository. And this versioning means that if something changes, we can track it and we can act upon it. And this is where this step comes in. So a CI/CD, which is continuous integration and continuous deployment. Basically, we react via hooks to changes in the code, which then get pushed in a repo. Then a whole process kicks off where, for example, unit tests can run at this step or integration tests. And the build can happen if the application requires a build step. All of these happens in the CI/CD phase. Then that gets deployed to a VM and the user accesses the code on the VM and the application there. Then we evolved again from that. We went from that environment to something called virtualization and Docker. Okay, so we basically add a way to define and explicitly specify what the server here, which was just running on a server somewhere, would need to function. We create a sort of a manifest of the computer which was needed to run the application. For example, we need FFmpeg or we need a specific version of Python. This was now not defined at the VM level or at the server level, but it was defined in a configuration file. This configuration file, which is called a Docker file, has steps that are needed to kind of bring that application to life. So from this step, we basically added in a virtualization file, which allowed to then deploy a container, which basically was a self-contained unit running on a VM or server with the file specification which we gave before. So we have now a container which is extensible, can be deployed in different parts easily, running on a virtual machine or a server, whatever you want, being deployed after a CI/CD step. And then you have the user connecting to it. So what situation are we on now? Now we develop locally. We have a configuration which mimics a cloud environment, and you can use something like Tilt. You can go to tilt.dev, as a great set of documentation, and we basically replicate the Kubernetes cluster environment. And once we have that, we feed the objects that we want to run via Tilt. So what does the process look like right now? We basically develop locally with Tilt, then we actually make changes to the app repo. We push the repo to the remote, We then have a CI/CD step, which can be seen as the step here, which runs the unit test, runs the build. Then when this step ends, it deploys or increments a version in a Git repo, which is the infracode repo. So this is your code as law. This is infrastructure as code. It's a declarative repository, which we'll see later what it means for a Kubernetes environment. And in this infracode repo, we specify which environment this deploy must go to for production or development. And we tag the latest version, which was created here, so that another CI/CD kicks off. So we have a change also in this repo. Then another CI/CD steps kicks off. And basically this step then pushes and builds and deploys the application to the Kubernetes cluster, which then has a node, and that application gets put into a node on a pod and then run the container, which we used to run here, and then the user can access it. And this way, it's a much, much better and replicable development method, because you know what everything changes, and you can control exactly what goes in which environment and with which resources, and also if you need to overwrite some files. So it's a great way to actually do software development these days. I hope you enjoyed this video and look forward for the next one.